Hello everyone, welcome back to my YouTube channel. My name is Srishti. I'm in my third semester studying in Sri Venkateshwara College of Engineering in the Department of Computer Science and Engineering. In this video, we are going to learn about stack and stack operations. Now let's learn about the content of this video. First, we're going to learn about the definition of stack and the stack operations, which are push, pop, overflow and underflow and stack applications. Let's move on to the definition of stack. A stack is a fundamental data structure. In a stack, elements are added and removed from the same end, which is referred to as top of the stack. A stack is a data structure that follows the last in, first out principle, the LIFO principle, meaning that the last element added to the stack is the first one to be removed. It is a linear list of elements. Let's learn the different operations of stack. There are many operations of stack. It can be envisioned as the collection of elements with two main operations, that is the pop and push. The other operations include underflow and overflow. In this diagram, you can see that push an item meaning insertion of an item and pop an item meaning deletion or the removal of an item. Now let's move on to the push operation. The push operation is used to add an element to the top of the stack. It increments the stack pointer and then stores the new element at that position. The syntax or the pseudocode of push operation is push, open bracket element, close bracket. In this diagram, you can see the functioning of the push operation. Here they have taken an empty stack with the top as -1. You increment it and you add a value to it and that becomes the top. Now the new top is 0. Now you add another element here, the top becomes 1. You keep incrementing it by 1 until the number of stacks are filled. Let's see a simple example for the push operation in C programming. First, you call in the standard input and output library using the keywords hashtag include stdio.h. Then you define the maximum size which is to be assigned to the stack using the keywords hashtag define max underscore size 5. You define it way before you start the program because you want the size to be constant throughout the program. Next, you call in an array with this maximum size with the data type int. And then as we have learned in the previous slides, a stack should always contain a top. Here we have taken the variable top and given it a data type int, assigning it a value of -1. Make sure you see here that you can assign any values, but I have taken here as -1. Now, to use the push operation, we have given a function named void push. And now let's call in the void push function. Here the function name is push and the function is void. It gives a int value inside the brackets if the function is called further on. Next, we have given an additional conditional statement known as if statement to check if the stack size is correct or proper or no. Here, if top is smaller than max underscore size -1, it then can, if it is true, then it can proceed to the next statements in the given function, or else it is it moves to the else statement. Let's see. Here our top is -1. Since it is smaller than 5 minus 4, which is 5 minus 1, which is 4, the next statements or the statements inside the if condition are followed. Here the stack is incremented. Since stack is -1, it becomes 0 and a value can be assigned to it. Then it prints that push %d on the stack comma value. That is %d value, the value which you have assigned is incremented into the stack. If the condition becomes false, that is 4 is not smaller than 4, it goes to the else statement and prints that error stack is full, cannot push this particular value into the stack. After all this, Let's erase this. After all this you can start the main program, that is int main, and call in the push function and assign it its values. You can add another push function, but if you do add it, shows the else statement telling that is there is an error. Then you return it to the function. The output is shown here. Pushed 42 into the stack, that is three numbers are added into the stack. Now let's learn the pop operation. The pop operation is used to remove the element from the top of the stack. Here we know that the top keeps getting incremented as we keep adding values or variables to the stack. So the top is the last element to be added. We know that the stack is also follows the LIFO principle, that is the last in first out. So therefore, the last element which is added here, for example, is T, is the first one to be removed, as shown in this example. Now, it retrieves the element at the top of the stack and then decrements the stack pointer. The syntax for pop operation is pop, open bracket, close bracket. Now let's see an example of pop operation. Now this is a simple example of pop operation. It is similar to the push operation, but there is an extra line given int pop. So let's learn about this. Here you call in the input output standard library and give the max size as usual, as we have seen in the last example. Then you call the stack size, you call in an array variable named stack and assign a value to the top as -1. You call in a function named push and assign a value into value to it. Here, the condition here given is top is smaller than max size -1. If this condition is true, you can keep adding numbers and and this is incremented and the number is added and the number is shown. If this sentence is wrong or is false, it shows this error, this printf statement, that is error stack full. Now, let's say int pop. Here int open pop. Here you return top, that is if the top is greater than or equal to 0, you keep removing the items. That is, you keep decrementing the value and decrementing the stack maximum size. And if the top is -1, which is not greater than or equal to 0, it printfs the statement error stack empty. This is just a simple example. I hope you can understand. You can go through it. Moving on, overflow and underflow. Overflow is the concept of a stack occurs when an attempt is made to push an element into a full stack. A fixed size stack, if the stack is already at its maximum capacity and another element is to be pushed, it leads to an overflow condition. Underflow in the context of a stack occurs when an attempt is made to pop on an element from an empty stack. Popping of an element from an empty stack is not allowed since there are no elements to be removed. Let's learn a small example on this. This is a small example which includes the previous two examples together in a single program. Here you can see that if the stack is empty, the printf error stack is empty can be seen. But if the stack is full, printf error stack is full cannot push %d is seen. You can go through this example and execute it. Let's move on to the stack applications. There are many different applications for stack. First one being function called stack. The function called stack is a specific application of a stack in the programming language. When a function is called, its local variables and the address to return after the function completes are pushed onto the stack. When the function finished execution, its stack frame is popped. Next is expression evaluation. Stacks are often used in the evaluation of expressions, such as converting infix expressions to postfix or prefix notations. The stack helps to keep track of operators and operands. Next one is undo mechanism in applications. The third application is undo mechanism. Many application uses a stack to implement an undo feature. Each operation that modifies the state of application is pushed onto the stack, allowing users to undo actions in reverse order. The last two are backtracking algorithms. Algorithms that involve backtracking often use a stack to keep track of choices and explore different paths. Parsing in compilers. Stacks are used in compilers for parsing and syntax analysis, especially in constructing abstract syntax trees (AST) during compilation process. I hope this video was helpful. Please do like, subscribe, and share. Thank you so much.